Something strange has been happening to Earth. For 3 days straight, satellites glitched, radio signals bent, and auroras bled across skies that should have been dark. The planet itself felt charged like a heartbeat racing beneath our feet. Scientists called it a prolonged geomagnetic storm, but no one saw it coming. No solar flare, no coronal blast. No warning at all. Just an invisible wave of energy that refused to fade, sweeping around our world for 72 relentless hours. And just as Earth's field began to tremble, something else was moving closer, an interstellar object named 3I Atlas, followed by a swarm of comets closing in from the outer dark. Was this just coincidence, or the first sign of a deeper cosmic chain reaction tonight? We follow the energy surge that no one can explain to see whether it began on the sun or beyond the stars. It began like any other pulse of solar wind, but refused to fade. For almost 63 hours, Earth's magnetic field remained in storm mode, fluctuating above G1 level and peaking at G3 for 6 straight hours. By comparison, the June G4 event was stronger in magnitude, but it passed quickly. Its energy spent within a day and a half. This time, there was no warning. No coronal mass ejection. No visible coronal hole aligned with Earth. The storm seemed to emerge from an invisible source, defying every predictive model scientists relied on. Satellite data from DSCOVR showed wind speeds surpassing 700 to 800 kilometers per second, while particle density plunged below 1 particle per cubic centimeter. This strange combination, high speed, low density, no clear origin, made the storm unlike anything seen this year. To some, it looked like a mystery of space weather, but for others, it was the first sign that something larger was at play. While most people focus on how strong a geomagnetic storm is, scientists often pay closer attention to how long it lasts. During the equinox, Earth's magnetic axis tilts just enough to align with the Sun's interplanetary field, a configuration known as the Russell-McPherron effect. When the interplanetary magnetic field, or IMF, tilts southward, it opens a direct channel for energy to flow from the solar wind into Earth's magnetosphere. Even a moderate solar wind, under the right alignment, can stay locked on continuously transferring energy for days instead of hours. That may be exactly what happened here, a geometry that trapped energy instead of releasing it. A modest storm in strength, but one perfectly positioned in geometry. Sometimes, the angle between Earth and the Sun can matter more than the power of the Sun itself. Not all solar activity comes from flares or eruptions. Some of it returns again and again from the same source. One particular coronal hole, now completing its 14th solar rotation, has become a familiar feature on the Sun's surface. Each time it faces Earth, it releases a high-speed solar wind stream, racing across space at hundreds of kilometers per second. These recurring streams act like periodic pulses, recharging Earth's magnetosphere again and again. On its 7th rotation, back in early 2025, this same coronal hole coincided with the magnitude 7.7 earthquake in Myanmar. Scientists have since tracked it closely, not as a prediction tool, but as a repeating pattern worth paying attention to. 14 rotations later, it's back again, facing Earth once more. Each rotation brings new data and new questions about how deep the Sun-Earth connection really runs. In the weeks surrounding this storm, the inner solar system has become unusually crowded. Several comets are now sweeping through the ecliptic plane each, leaving trails of gas and microscopic dust. C-2025 R2 Swan lies almost exactly on the ecliptic, reaching its closest point to Earth in late October. C-2025 K1 Atlas reaches perihelion, its closest approach to the Sun, around October 29 to 30. C-2025 A6 Lemmon is brightening rapidly, expected to cross the ecliptic in November, and 240 P-NEAT is moving inward between Mars and Jupiter. expected to peak in December. Each of these objects releases a diffuse trail of dust invisible but electrically active. Inference. That dust may slightly modify the plasma density of interplanetary space, subtly shaping how solar particles flow toward Earth. Speculation clearly marked a recent coronal mass ejection directed toward R2 Swan might have collided with that dust field, temporarily making the solar wind denser and more conductive. It's an intriguing idea, one that fits the timing, but it still needs quantitative confirmation. For now, it reminds us how delicate and interconnected our solar system truly is. Among the many comets racing through the inner solar system, one stands apart, 3I Atlas. It is officially the third confirmed interstellar object, following Oumuamua and 2I Borisov. Its near-linear path and extreme velocity prove it came from far beyond our solar system, a true interstellar traveler. 3I Atlas will reach perihelion, its closest point to the Sun, around October 29 to 30. A week earlier, on October 21, it will enter superior conjunction, perfectly aligned behind the Sun with Earth and the Moon. From Earth, it will vanish in the Sun's glare, but Mars probes will have a clear view. Inference. Such a perfect alignment during solar maximum is statistically rare, a geometry worth continuous monitoring. Any subtle interaction could help scientists understand how interstellar plasma may influence the Sun's own magnetic flow, deep beneath the auroras and solar wind. Another field hums quietly, the Schumann resonance. It measures the standing electromagnetic waves trapped between Earth's surface and the ionosphere. Under normal conditions, these modes resonate at 7.8, 14, 20, and 26 Hz. But recent data from Tomsk, Russia, revealed something unusual, a strong fifth mode at 33 Hz. Inference. It's most likely a local artifact, not a global shift. Heavy cloud systems, local storms, or even power inverters can mimic such signatures on the spectrogram. When reading the Schumann field, it's crucial to separate local weather effects from planetary scale energy. Only then can the data truly reflect the heartbeat of Earth itself. Every geomagnetic storm leaves something behind, not just light in the sky, but currents deep within the Earth. Fluctuating magnetic fields induce powerful electric currents through the ionosphere, the crust, and even the mantle. After long storms, Earth's radiation belts begin to reorganize, a slow resetting process that can last for weeks. Inference energy redistribution takes time, sometimes overlapping with seismic aftershocks or volcanic outgassing. The connection isn't proven, but the timing remains intriguing, suggesting that Earth itself may breathe after each magnetic storm. As Earth's magnetic field settled, another kind of energy began to stir beneath the surface. In just a few months, the planet has seen a remarkable series of seismic events. Magnitude 6.9 in the Philippines, Cebu. Magnitude 7.4 and 7.5 in the Drake Passage, May and August. And the magnitude 8.8 megaquake in July 2025, the strongest in over a decade. By now, 2025 already ranks as the 6th most seismically active year since modern records began. Inference. Some researchers note a strange antipodal resonance between Kamchatka and the Drake Passage, quakes echoing across opposite sides of the Earth. It may hint at how deep seismic energy redistributes globally over time, but no deterministic link to space weather has been proven, only patterns worth continued study. As magnetic storms ease, the Sun itself is showing signs of a complex rhythm. The number of visible sunspots dropped slightly from 133 in August to around 130 in September. At first glance, it looks like solar activity is calming. But history tells a different story. Inference. This small dip may mark the formation of a second peak, a pattern known as the dual crest of a solar maximum. Such double peaks often occur near a magnetic reversal. when the sun's north and south poles begin to switch places. If that's the case, solar activity could intensify again before year's end. The second crest of solar cycle 25 is now taking shape just hours after the geomagnetic storm reached its peak. Fire erupted from below. Hawaii's Kilauea volcano entered its 34th eruptive episode, sending lava fountains soaring more than 400 meters into the air. The eruption lasted nearly 8 hours, painting the night sky in crimson and gold. Inference: while no causal link has been proven, the timing is impossible to ignore. It's a vivid reminder that energy manifests both above and below in plasma and in magma. The Earth and the Sun too fires. One eternal dialogue. As the storm subsides, the next phase begins observation. Key indicators to watch over the coming weeks fall into 3 domains: solar, cometary, and seismic. Solar, when the interplanetary magnetic field, known as BZ, drops below -10 nanotesla for more than 2 hours. Comet, when R2 Swan brightens to naked eye magnitude, visible from mid-latitudes. Seismic, when any new magnitude 6 or higher aftershocks appear within current active clusters. Inference: if these 3 signals occur together, it could mark the next critical data window. The universe doesn't repeat, but sometimes it rhymes. Maybe this was just another storm, or maybe a reminder of how little we still understand about the invisible forces connecting the sun and the Earth. The data are clear, the meaning is still unfolding. Every measurement brings us closer, not to answers, but to better questions. So if you'd like to follow the next phase when new readings arrive, subscribe and stay on watch. Between science and silence, there's wonder, and we are still listening.